research in artificial intelligence. Basically, we are trying to apply artificial intelligence in surveillance. I think my current speaker, Dr. Godiva, has given us quite some insight about artificial intelligence. But now, since we are short of time, I would like to start the presentation with a bit of a scenario. I would like us to first of all imagine, as we were outside there having our lunch, if somebody came in here and maybe took a camera, how would we know who was it? When was it done? I think CCTV. Yes. So we have cameras here. But how long would it take us to actually get that information? Yes, we would all know that it was taken during lunch break. So we would have something like an hour or an hour and a half of footage that will have to be reviewed by a certain individual for us to actually get to know who did what. So I want us to imagine if we had a system that could give us that evidence in less than a minute or less than 5 minutes. This is where we are bringing in artificial intelligence into surveillance. As we can see, surveillance cameras have been adopted wide in universities, even on the roads now. Our president installed cameras for us. But for those of you who have not had a chance, or maybe an audio that requires you to go to the command center, retrieve that footage, you may not know that it is next to impossible to have that footage. Because one, we are going to be looking at the time that is going to be required to go through all that footage. Two, it is tedious. Just like I talked about the 1 hour or 1 hour and a half of footage to be reviewed. It takes a lot of time. And to make matters worse, at times it is inefficient because the people we have in those control rooms tend to dictate what they deem criminal and what is not. Then that brings me to the last problem, which is how subjective manual reviewing of surveillance footage is. This is because it hinges so much on your human input. The person in that control room gets to decide whether they can access that footage or not. The person in that control room gets to decide what is a crime and what is not. But imagine if we had a system that would call out a crime once it comes across it. This is one way we can try to leverage AI in the surveillance domain. So the research questions for this study are: can machine learning be leveraged to reduce the time of searching through long hours of footage for scanty evidence of the crime? Number two, can the dependence on human judgment in retrieving this criminal evidence be minimized? Brings me to what I'm doing about this. I'm using two deep learning algorithms to minimize the time we need to review the footage, and also, to some extent, try to eliminate the dependence on human judgment. So one of the models that I'm using is, one of the algorithms that I'm using is object detection. Object detection, in a layman translation, I would say, this helps us to identify objects. Let's say if you've been to the airport, those people don't really need to go through all your bags, but they will scan your bag, and those algorithms embedded in those scanners are able to detect each and everything you have put in your bag. So these algorithms have been used in those more developed countries in facial reconstruction, identifying weapons. You know, these things you find are mysterious back there. We are all wondering what is there, what is not there. In those countries, these algorithms can simply tell them what is in the bag. So I am using this algorithm together with long short-term memory models. Now these LSTM models are artificial intelligence models, but they have the capability of storing memory of something they have been trained on. To talk about the data set briefly, I'm using the HR crime data set, and this data set consists of crimes that are being clustered in 13 classes, that is abuse, arrest, assault, burglary, explosions, fighting, road accidents, robbery, shooting, shoplifting, stealing, vandalism. These are crimes that were selected because they are more closer to us. And for this work, we, as I've already said, object detection algorithms are already in use, but they have not been quite adopted in the surveillance domain. So we had to do a comparative study on these deep learning algorithms that are available on the market to try and find out which one performs best with surveillance footage. One of the major challenges with surveillance footage is that most of the times it is not clear, it is dark, there is a lot of noise. That's why we find ourselves most times we have police reports not coming out because blurry pictures are not happening. So we found it important to find out how these object detection algorithms perform with surveillance footage. And from our study, we found out that the YOLO version 8 object detection tool outperforms its counterpart, the single shot object detection tool, with a mean average precision of 97%. So from this, we chose to work with the YOLO version 8 object detection tool. Now, what we get from this tool only helps us to detect given surveillance footage. First of all, is there any human in that footage? So the system will only look at frames where there are human beings or human activity. So this helps us to reduce on the time that you would take reviewing footage of this room when we were all out for lunch. So it starts its detection from when an individual entered the room. That is the part of object detection. So for it, it's going to give us your spatial information. Spatial information, I mean where you are in the footage and probably what you're doing. So we are going to take this information and use it to train our LSTM model. Remember the other one I talked about that has the long short-term memory. So we use it to train that model in order to understand what humans are doing, to understand the human activity. So we are only able to do this with enormous amounts of data. For this case, we had a total of around 950 untrained videos in the different classes of the crime. So now, from the training of our model, these are our results. Unfortunately, this has been cut out. But on this axis, we'll have the true values, like what is true, that even a human can see that it's true. And on this axis, we have what was predicted by our model. We have this 0, 1, 2, 3. These are classes or categories of the crime. So for this, we had 11 classes. I will still explain why in the conclusion, because we had 13 from the data set. So this clearly shows you that for class 0, the model was able to correctly classify 123 instances and only misclassified 2. When you look at this diagonal path going down, it shows us what our model got correctly. So for class 0, it means it had 125 entries. It correctly classified 123 and only missed out on 2. So from that confusion matrix, we can clearly see that the model does a good job, because sometimes there are some false positives and false negatives. We have other evaluation metrics, such as the F1 score. This gives us the balance between the precision and recall of the model, and our model score is 0.96, which is indicative of a good performance. Then Matthew's correlation coefficient also helps us to know how close our model's prediction is, how close it is to the actual thing that it is supposed to. Yes. Now, these precision and recall curves you see here are for the 10 classes that we had. We see that our precision tends to 1 for most of the classes, through a depiction of what we are seeing here. That is just a confirmatory test of these results that we have seen there. So in conclusion, we say that this model is more than capable of helping us get rid of that problem of the long hours and dependence on human judgment. However, just like I said, we had 13 classes in our data set, but we only ended up working with 10. This is because our object detection tools currently need to be further fine-tuned to work better with surveillance footage for some more complex crimes. For example, explosions, arsons. It becomes really hard for the tools to detect where the human is in case of a fire outbreak. So we need to further fine-tune that. In future, we also plan to investigate the integration of additional information sources, such as environmental data and social media activity, to further enhance crime prediction capabilities.